Hi, today I will present the paper Middleware in Modern High-Performance Computing System Architectures. It was published in International Conference of Computer Science on May 27, 2007. So fun facts here. All of these products or company or the mergings, whatever, all these things will happen back in 2007. So the introduction. High-performance computing, also known as HPC, or the supercomputer. The idea here is to understand the concurrent network computing has just become a trend at a time. By editing the OS features on the certain machines, creates clusters or grids, then execute the applications with parallel or distributed programming through runtime environments. Applications used in real time include weather forecasting, astrophysics research, stock market, etc. Some examples for HPC architecture. In Figure 1, as you can see, head node, compute nodes, and interconnects can be customized to their specific purposes to make improvement. Because the structure is simple and flexible, many supercomputer vendors adopt the Beowulf architecture either completely in form of HPC clusters, or they develop the hybrid HPC solutions. And in Figure 2, a number of compute nodes perform the actual parallel computing, while a head node controls the system and acts as gateway to users and external resources. Optional services node maybe offload specific head node responsibilities to improve performance and scalability. And more to the architecture. Here's a comparison for traditional versus modern lean compute node software architecture. System software, such as OS and middleware, has been influenced by HPC as well, but also by the needs for customization and performance improvement. Similar to Beowulf cluster system architecture, system-wide management and gateway services are provided by head and service nodes. In contrast of traditional clusters, today's HPC system typically employ lean compute nodes, as you can see in the right side of the Figure 4, with a basic OS and there's only small amount of middleware services, or if there's any middleware at all. A certain OS parts and middleware services are provided by service nodes instead. So fun facts again, these are not existing in 2007. I'll just let that sink in for a second. Okay. So as example shows on the slide, each middleware layer is typically an individual piece of software that consumes system resources, such as memory and processor time, and provides its own core mechanisms. In fact, middleware becomes an external application support. Also, single middleware services on the service nodes provide support for multiple compute nodes via the network. They still perform the same role, but in a different architectural configuration. While middleware services, such as daemons, run on service nodes, the RTEs, runtime environments, continue to run on compute nodes either partially by interacting with middleware services on service nodes, or consider a standalone solution. In both cases, RTEs is dealing with existing limitations on compute nodes, such as missing dynamic library support. In the discussion, the authors provide samples for these bullet points. First is the functionality. The software architecture of modern HPC middleware needs to be adapted to a service node model, where middleware services running on the service node provide essential functionality to middleware clients on compute nodes. Performance and scalability. Due to the need of middleware clients on compute nodes to communicate with middleware services on service nodes, many middleware use case scenarios cause a certain latency or bandwidth penalty. On top of that, central middleware services on service nodes represent a bottleneck as a single point of failure and control. Reliability, for instance, middleware service offload, load balancing, and replication techniques may be used to alleviate performance and scalability issues, and to eliminate single points of failure and control. Slimming down, because of the lean structure of the HPC, there are limitations in middleware solutions, while performing RPC call to service nodes to interact with middleware services. Certain missing features, such as absence of dynamic linking, are difficult to replace. Service-oriented middleware architecture. The shift towards the service node model for middleware has certain architectural advantages. Middleware services may be placed on I/O nodes to facilitate advanced I/O based online or real-time services, such as application steering or visualization. The conclusion from the authors. It aims at improving overall system performance and scalability by keeping the compute node software stack small and simple. Thank you.